So in the previous session we have studied about queue, the different types of queues as well as the operations of queues. So what is a queue? A queue is a collection of items where insertion and deletion of an item takes place at different endpoints is called as a queue. So what are the operations we can perform? That is queue operation, queue function to create an empty queue, and next one is enqueue, that is to insert an item into the queue, dequeue to delete an item from the queue, is empty to check whether the queue is empty or not, and size function to return the number of items from the queue. When comes to the types of queues, there are 4 types, that is simple queue, circular queue, priority queue as well as double-ended queue. In this session we are going to see the different representation of queues. So in queues we have 2 representations, that is memory representation of a queue using arrays as well as a linked list. Memory representation of a queue using arrays. So queue is a linear array. We are going to represent queue in memory as a linear array where insertion of an item takes place at the end point of the queue called as rear, and deletion of an item takes place at the front point of the queue called as front. So this is called as front and this is the rear of a queue. So these are all the indices. So front is equal to 1 and rear is equal to 4. So if I want to add an item called E, then what we have to do? We have to increment the rear pointer. So now the rear is 4. So if I want to insert an item into the queue, I have to increment this rear to 1. That is rear is equal to rear plus 1. So this is for adding an item. Adding an item into the queue. So we have to increment the rear pointer. Then we have to insert an item to the rear of the queue. Rear of the queue. Here queue is a linear array. We are inserting an item to the rear of the queue. Now the array becomes C, D and E. So now the front becomes as it is 1 and the rear becomes 5. Rear becomes 5. So this is the rear point and this is the front point of the queue. So while removing an item from the queue, we are removing from the front end of the queue, right? So that is item is equal to queue of front. Queue of front. So if I want to delete this item A, then I have to remove from the front end of the queue. So next, after deleting this, front is going to be incremented by 1. So now the array becomes Now the front becomes front plus 1. So that is, and rear will be the same. Now front becomes 2 and rear becomes 5. Rear becomes 5. So this is the array representation of a queue. Another type of representation of a queue is using linked list. So using linked list. So we can represent a queue using linked list also. So in queues, an item should be inserted at the rear end of the queue and deletion of an item should take place at the front end of the queue. The pointer front contains the location of the first node in the linked list and the pointer rear contains the location of the last node in the linked list. So see here, so this is the header, this is the head pointer which contains the address of the first node of the linked list, and this first node contains the address of the next node, and this node contains the address of the last node. So this is the front pointer and this is the rear pointer. This is the front pointer and this is the rear pointer of the queue. So if I want to insert an item into the queue, so what we have to do, at the end I have to insert an item called 40. An item called 40. So what we have to do, we have to first, so this head pointer contains the address of the first node and this node contains the address of the next node and this contains the address of the last node. So after this node I have to insert an item called 40. So this node contains two parts, that is the first part is a data part and second part is a link part. So in the link part I have to give link to the next node by creating a new node. So in this node, in the data part I have to insert an item. In the link part I have to write it as null. Null represents the end of the link. End of the link. So this is how we are going to represent a queue using linked list. So if I want to remove an item from the queue, how to remove an item from the queue? Always item should be removed at the front end of the queue, right? So I want to delete this item, that is 10 from the queue. So for that what we have to do? So in the head pointer I have to give the link of the second node. So here we have to create a link to the second node of the linked list. So here an item gets deleted. So now the linked list contains only 20, 30 and 40 as its items. So this is how we are going to represent a queue using linked list. Now let's see an algorithm for how to insert an item into the queue as well as how to delete an item from the queue. So here insertion of an item is nothing but enqueue operation and deletion of an item is nothing but dequeue operation. Enqueue and dequeue of an item. algorithm for insertion. So now let's write the algorithm for insertion. So let Q be the linear array with n items, front is the pointer, which contains the location of the item to be deleted, and rear is the pointer, which contains the location of the inserted item, and item is the element to be inserted. So these are the prerequisites. So what is the first step? While inserting an element into the queue, we have to check for overflow condition. What is the meaning of overflow? If the queue is full, then we call it as a overflow state. So if Q is equal to n minus 1, then print Q is full. Or we can say it as overflow. If it is overflow, we cannot insert an item into the queue. So we are returning from the queue. We are checking for another condition, whether it is empty queue or not. So if front is equal to null or minus 1, we can say it as minus 1 also. If front is equal to null, then front is equal to 0, rear is equal to 0. So if the queue is empty, then the pointer front and rear is equal to 0. Else, if this queue is not empty, then we can insert an item into the queue at the rear end of the queue by incrementing the rear pointer by 1. So rear is equal to rear plus 1. So at the end of the queue, we are inserting an item. So that is queue of rear is equal to item. So after inserting an item into the queue, we are returning from the queue. So what is the first step? First step is to check for overflow condition. That is whether the queue is full or it is in overflow state. So if the queue is already full, we cannot insert an item into the queue. So for that we are checking for the condition. If queue is equal to n minus 1, then we have to print it as q is overflow and we are exiting from that. So in the next step, we are checking for another condition, that is q is empty or not. That is, if front is equal to null, then the front as well as rear pointer is obviously 0. It does not contain any item, means front and rear pointer is also 0. Else we can insert an item into the queue by incrementing the rear pointer, that is rear is equal to rear plus 1. So at the end of the queue we are inserting the item, that is q of rear is equal to item. So after inserting an item into the queue, we are returning from the queue. So this is the algorithm for insertion. Now let's see the algorithm for deletion of an item from the queue. The algorithm for deletion of an item from the queue. So here let q be the linear array with n items, and front is a pointer which contains the location of the item to be deleted, and rear is the pointer which contains the location of the inserted item. So here item is the element to be deleted. So this algorithm deletes an item from the front end of the queue. So before deleting an item from the queue, we have to check for the condition, that is whether the queue is underflow. So here we are checking for the underflow state, that is if front is equal to null, then we have to print it as q is underflow. Q is empty, we cannot delete any item from the queue. So we are exiting from this. So in the next step, we are checking for the condition. So if the queue is not empty, we can delete an item from the queue. That is, we are deleting an item from the front of the queue. We are deleting an item from the front end of the queue. Right. So after deleting an item, we are checking for the condition, whether the queue contains only one element. If the queue contains only one element, so after deleting that item from the queue, so the queue becomes, if front is equal to rear, then, so see here in this queue, so it contains only one element. Right. So I am going to delete this item from the queue. So if I delete this item from the queue, the front and rear becomes null. So it becomes null. Front as well as rear becomes null. So if this condition is false, then we can increment the front to the next position of the queue to delete another item from the queue. Else, increment the front pointer. So front is equal to front plus 1. So after deleting an item from the queue, we are returning from the queue. So while deleting an item from the queue, we are checking for whether it is empty or not. We can call it as empty or an underflow state. So if it is empty or underflow, we cannot delete an item from the queue. So we are exiting from the queue. So if the queue is not empty, we can delete an item from the queue, that is from the front end of the queue. So item is equal to queue of front. So after deleting an item, we are checking for the condition whether the queue contains only one element or not. So if it contains only one element, then the pointer front is equal to rear. So it becomes both pointer front as well as rear becomes null. So if the queue does not contains only one element, we can increment the pointer front to the next position of the queue to delete the next element of the queue by front is equal to front plus 1. So after deleting an item from the queue, we are returning from the queue. So this is the algorithm for deletion of an item from the queue. In the next class, let's see how to write a program for this insertion and deletion of an item from the queue. Thank you.